before moving forward, I want to do a very quick summary of domain and sketching of functions. For a more detailed explanation of this, you can look into khanacademy.org or another YouTubers who are more into the theoretical explanation of this topic. I'm going to be very brief, and I assume that you have some sort of understanding of this area. So let's begin with constant functions. Constant functions look like this: y equals k. K is a real number. So we can have y equals 3, y equals 5, y equals minus 8, y equals square root of 3, whatever. The plot is going to be a straight horizontal line that is parallel to the x-axis, and it cuts the y-axis at precisely the value of k. So if we have y equals 5, then the cut at the y-axis is going to be precisely at 5. Domain of constant functions, all the real numbers. No restrictions, they exist all across the board. Number 2, linear functions, as in line, linear, straight line. They look like this: y equals mx plus b. M and b are constant, real numbers. M represents the slope, and b, the cut with the y-axis. When we plot this in our x, y, the graphical representation is going to look like this: a straight line pointing upwards if m is positive. It's going to point downwards if m, the slope, is negative. And it cuts the y-axis at the value of b. Domain, all the real numbers, no restrictions at all. Number 3, polynomial functions. First time we probably heard that word, we freaked out, we got scared. We asked ourselves, whoa, is that going to eat me? Is that going to... Wow, scary. But nah, they're not scary at all. They look like this: y equals ax power to n plus b x power to n minus 1, and so forth. Independent term c. A, b, all the coefficients of the variables, and c are constant, real numbers. Domain of these functions, all the real numbers, no restrictions. They exist all across the board. So when we plot them in our xy axis, they're going to look like a curve, and all across the board, all over the x real straight line. So it can look like this. It can look like a parabolic curve, upwards, downwards, doesn't matter. The bottom line is that the domain is all the real numbers. Number 4, all these 3 functions, by the way, no restrictions. They exist all across the board through the real numbers. Number 4, divisions. Here's where we're going to find our first restriction for existence. They look like this: y equals something numerator over something denominator. And here's where the restriction part is going to come in. The denominator can't be 0. The denominator of the function cannot be equal to 0. Why? Because if you have a constant, divided by 0, that equals either positive or negative infinite. So that doesn't exist. We cannot compute that. We don't know what that means. So that's where the restriction is. Number 5, radical functions, as in roots. Also the scary things. There's 2 types of roots regarding domain of functions. Those with even exponent, as in square root, 4th root, 6th root, 8th root, and so forth. And also odd exponent roots, as in cubic root, 5th root, 7th root, 9th root, and so forth. Now, the issue here of existence, or the restriction, is going to only apply for even exponent roots. Why? Because we have to guarantee that's what inside the root has to be positive. There is no square root of negative numbers. There's no square root of negative numbers. There's no 4th root of negative numbers, and so forth. We're going to look more into this in the following exercises. Number 6, logarithmic functions, or logarithm, whichever way you prefer. They look like this: y equals log of x. They have a base, And when we plot them in our xy axis, they're a function that grows constantly. Here we go, xy axis, cuts the x-axis in 1, coordinates 1, 0, has a base, n is a natural number, and the restriction here comes from the argument. Whatever it's inside the x has to be greater than 0. It has to be positive. It can't be 0. It can't be a negative number. It has to be positive. Whatever it's inside the argument cannot be greater or equal than 0. It has to be greater than 0. Positive. It doesn't cut the y-axis at any time. Number 7, exponential functions. Exponential. They look like this. Y equals a being a constant, power to x. So we can have 2 power to x, 3 power to x, number e power to x. That's a very famous one. A is a real number, so whichever you want. The variable is the exponent. They look like this when we plot them. It's a function that keeps growing a little bit more aggressively. It's the inverse of a logarithm. Cuts the y-axis in 1. Why? Because remember that any number powered to 0 is going to equal 1. So 2 powered to 0 equals 1. 3 powered to 0 equals 1. A powered to 0 equals 1. We can do a couple of more examples. Like, for instance, if you were to have the number e powered to 2, it's gonna be equal to some number, doesn't matter. What I want to show you is that if you have e powered to negative 2, that's going to be equivalent to having 1 divided by e squared. The negative sign sends the number to the denominator. So if we were to have e powered to minus 3, that would be equal to 1 divided by e cubed. Domain of exponential functions, all the real numbers. No restrictions at all. And then we have trigonometric. Sine, cosine, tangent, cotangent, and so forth. They're going to have their own restrictions, and we're going to talk about them more detail in further videos because they're kind of particular on their own. The bottom line of this video is, like I said, I want you to understand briefly the domain, the restrictions, and the graph of the different types of functions. Beware of the restrictions. That's the important thing that I want you to learn from this video, because the restrictions is the areas where the function doesn't exist. So again, if you look at constant, linear, polynomial, they have no restrictions at all. Divisions, they do. Radicals, they do. Odds, they don't. So we have to understand, when do they exist? Logarithmic, they do. Has to be positive. Exponentials, they don't. Trigonometric, we're going to explore more into further videos. Again, mind the restrictions.